students. We left off on this slide right here, and we were talking about heterogeneous and homogeneous mixtures, and how with a heterogeneous mixture, if you take a sample from the different phases, say you took a sample from the Kool-Aid up here, so this was the Kool-Aid with way too much sugar example, and you took a sample from down here, where we have the too much sugar sitting on the bottom, we said that you would find that those two different samples had different characteristics, different physical and chemical properties like melting point, boiling point, flammability, uh, electrical conductivity, density, etc. And we've been talking about physical and chemical properties along the way, but we haven't exactly defined them yet. So let's take a look at a chart of physical properties. So these are properties of an object or a substance that can be measured without us changing the identity of the substance. So a physical property might be the color. So what color is it? How intense is it? The state of matter, is it solid, liquid, or gas? The melting point, the boiling point. And an example would be, say you have a liquid water and you want to see what the boiling point of that liquid water is. So you want to know what the boiling point is, and so you put a thermometer in that liquid water and you heat it up and watch to see what temperature it boils at, and you find that it would be 100 degrees Celsius, which is 212 degrees Fahrenheit. But you have the same substance before and after. So before you'd have liquid water, and that's H2O, and then in parentheses we have an italicized L. So it's not an E, it's just a fancy L. And then after the change, you still have H2O, it's just in the gas state. So you have H2O before and after. So some other physical properties, density, solubility, so what it dissolves in or what your substance dissolves, what other substances it might dissolve. Electrical conductivity, like with copper, we would see that copper is a really good conductor. Malleability, that means can you bend it? So if you go in the kitchen and grab a spoon and get really aggressive and bend it, you can say, ah ha ha, my spoon is malleable. Ductility, can you draw it into a wire? So copper would be an element with high electrical conductivity and a high level of ductility. We pull copper into wires, and that's the metal that we most often use in our wires. And then at the bottom, we've got viscosity. So viscosity, it says there, how easy will a liquid flow? Viscosity, actually, it's better to define it as a resistance to flow. So something that's really viscous doesn't flow easily. It's thick and goopy, whereas something that doesn't have a high viscosity flows well. So something like oil would be a lot more viscous than water. And we hear about viscosity when we hear engine oil commercials. They'll brag about their oil's high viscosity. So we can classify our physical properties into extensive properties and intensive properties. And extensive properties, those depend on the amount of substance presence. Can't talk tonight. Present. So like mass or volume. So if you have more of the stuff, you're going to have a higher mass and it's going to take up more space, so you have a higher volume. And intensive properties are properties that don't depend on the amount of substance present. So water boils at 100 degrees Celsius. That's the boiling point for water. And it doesn't matter if you have 1 liter of it or 4 liters of it. It's still going to boil at 100 degrees Celsius. Now, physical changes. This is a change in a physical property of a substance. So say we change state. So here we have liquid water and we'll change the state to gas. And what you have is the same substance before and after the change. So down here we have H2O, it's just in a liquid state. And after the change, we still have H2O, but it's in a gaseous state. So that's physical change. And that brings us to the change in state triangle. So we know that if we want to go from a solid to a liquid, that's called melting. We all know that one. And if we go from a liquid to a solid, we generally call that freezing. But in chemistry or in science in general, we call that solidification. Now, the reason is because if you have water, so that's liquid H2O, and you watch it turn into ice, which is solid H2O, that happens at a really low temperature, 0 degrees Celsius or 32 degrees Fahrenheit. So it feels cold to us. So that makes sense that it's freezing. But what if we didn't have water as our liquid? What if we had some other substance that was our liquid, like liquid aluminum, so molten aluminum? So what we have is liquid aluminum. And how you get a liquid aluminum is you heat up solid aluminum to above 660 degrees Celsius. So aluminum melts at 660 degrees Celsius if heat is going into the system. But say you're at 700 degrees Celsius and you start cooling down to 660 degrees Celsius. So 660 degrees Celsius or below, your aluminum will start to go from a liquid form into the solid form. Now that's a really, really high temperature. So we don't tend to call that freezing, even though it's going from liquid to solid. But because it's such a high temperature, it makes more sense to us if we call it solidification. So freezing is solidification. It's just that with the word freezing, we attach that to a cold state. So solidification can definitely happen at a temperature where humans don't feel like it's cold. Okay, so going from a liquid to gas, we've got evaporation. And if we're going from a gas to a liquid, that's condensation. And we experience both of those in everyday life. When we go out to our car early in the morning and it's chilly, you'll see condensation, water droplets on your windshield. And that's because the water that is in the air, and you do have water in the air you're sitting in right now, it's just in the gas form, it hit a cool solid and it condensed. Okay, that would be the windshield. And we see condensation when we have a really cold cup on a warm day. The gaseous water that's in the air hits the cold cup on the outside and forms water droplets. And a lot of people think that the cup is leaking, the water inside the cup is going to the outside, but that's not what's happening. The gaseous water in the air is condensing on the outside of your cup. Okay, so say we want to go from solid straight to a gas. That's called sublimation. And that happens when we have solid carbon dioxide. That goes to gaseous carbon dioxide. And we see that when we have dry ice. The dry ice doesn't go through a liquid form like solid water, solid H2O does. What happens to the CO2 is it goes right from the solid into the gas state. So if you don't want soggy sandwiches in your cooler, you might pick up some dry ice, which again is solid CO2 because there's no liquid state. Now, going the reverse direction, gas to solid, is not something we usually run across in real life, but that's called deposition. Okay, so how we also might have seen dry ice is on Halloween. You might have one of these buckets and you throw in some dry ice and some magic punch on the top, and then you have this cauldron here of nice Halloween juice, and you get nice and happy. And that brings us to chemical properties. So a chemical property is a property of a substance that becomes evident when you have a chemical reaction. So you have a different substance when you finish the chemical change, which is also called a reaction, than you had when you started. And these chemical properties, a few of them are down here. We've got flammability, acidity, corrosiveness, and toxicity. And probably the easiest one to understand is flammability. If you want to see if something's flammable, you have to do what to it? You have to light it on fire. And once you burn it, it's going to be something different than you had originally. So if you have paper and you want to say, hey, I wonder if this paper is flammable, and you light it on fire and it burns, then, well, you're observing that chemical property and it's undergoing a chemical change or a chemical reaction. And the paper that you had in the beginning is no longer paper after the chemical change, it's a bunch of ashes. So again, different substance before and after with your chemical change. Another example is iron. So the nail right here is made up of a bunch of iron atoms, but if it undergoes oxidation, so it reacts with oxygen, it will form iron oxide. And iron oxide is what we commonly call rust. Now, iron and iron oxide are definitely different substances. You would not build a bridge or a bicycle out of iron oxide, but you might build a bridge or a bicycle out of iron. So different substances before and after, and you can't easily get back your original substance. You can't go from iron oxide to iron very easily. Whereas if you're undergoing a physical change, like going from liquid water to gaseous water, a lot of times you can easily get back to the original state. In this case, you would just cool it down. So that brings us to this slide right here where it shows examples of a physical change and a chemical change. So again, remember with your physical change, you have the same substance before and after. It's just going to change its appearance somehow. So here we've got solid sucrose. So sucrose is our white sugar that we use in the kitchen for baking. And you can see there it's C12H22O11, and in parentheses it says S for what? For solid. And then we're going to put it into water. And the sucrose is still sucrose when it dissolves into the water. It doesn't come apart and turn into something else. And you can see here it's still C12H22O11. It's just that in the parentheses right there we've got AQ, which indicates what? It indicates that it's dissolved in water, and that is aqueous. So it means whatever is right here, it's dissolved in water. So we can see here that in the solid, the sugar molecules are right next to each other. And then when we dissolve them, you still have intact sugar molecules. They're just farther apart because they're dissolved in water. And you can get your solid sugar back you would just do what to this solution? You would just boil off the water, or you could let it sit on the counter and let the water evaporate, and eventually you would have a solid sucrose back. All right, so the chemical change down here. What we have is we have a can of propane. And propane is what we use for our barbecue. So we have a can of propane, and that is C3H8, and it's in the gas form. So what we do is we burn it in the presence of oxygen. So it needs oxygen to burn. And naturally occurring oxygen, the stuff that we breathe, is O2 there. So the propane reacts with the oxygen and it produces CO2 and water. So what we usually notice that burning propane produces is light and heat, and we don't see the CO2 and the water because they're in the gas form. So you wouldn't see water dripping off of this because it's not in liquid form, it's hot, it's in the gas form, and it just takes off. But what you'll notice from this is you don't have propane before and after. You've burned it. It's turned into something else. It turned into carbon dioxide and water. So that's a chemical change. You don't have propane when you finish. So let's do some problems here. So let's decide if we've got chemical or physical changes here. So we're going to saw a log in half. So do you have wood before and after you saw the log in half? Yes. Okay, so you have the same substance before and after. It just changed shape, and that's just a physical change. So we've got physical here. Now, I always get one student in the class who gets really particular and says, well, what if the saw was causing friction where it was being sawed, where it was sawing the wood, and the friction caused heat and it burnt the wood? Well, then that would be a chemical change. But if I don't say something like that, just keep it to the basic question that I'm asking. I'm not trying to trick you in this class. All right, so melting chocolate in a pot on your stove. Do you have chocolate before and after? Yes, you have the same substance. You have solid chocolate or you have liquid chocolate. So you're not changing it to a different substance. So this is what kind of change? This is a physical change. What if you start texting with your boyfriend or girlfriend and you forget about your chocolate on the stove and you burn it? What kind of change is that? That's a chemical change because you don't have chocolate after that change. You burnt it, or not any kind of chocolate that you want to eat. So that one is chemical. You don't have chocolate before and after. What about if you drop a penny in acid and the metal that's inside, that copper, so what we have these days is zinc metal in a copper shell, and the zinc metal reacts with the acid. Well, that's a chemical reaction. So you don't have your zinc metal after you have done the change, it's gone. So that is what kind of change? That is chemical. What about cutting your hair? That's just changing the shape of it. That's physical. So you've got the same hair on your head and the same hair on the floor. It's the same substance before and after. What about if you dye your hair? So dyeing your hair. Well, that's definitely got some chemicals in that dye. And yes, it does change the structure or the chemical makeup of your hair. So it strips out the pigment or it adds some kind of dye in there. So you are changing what you had before, from before to the after. So that one is a chemical change. All right, so that is the end of this lecture. So we will go on in chapter 1 in the next lecture, and I will see you then. Okay, bye-bye.